In this lecture, we will discuss data design. You have data structure is a framework for organizing, storing, and managing data. It consists of files or tables that interact in various ways. Each file or table contains data about people, places, things, or events. An example would be, a data design example would be, Mario relies on two file-oriented systems that store data in separate files and are not connected. You have the mechanic system uses the mechanic file to store data about shop employees, and the job system. It uses the job file to store data about work performed at the shop. The Danica's Auto Shop uses a database management system with two separate tables that are joined so that they act like one large table. In the Danica shop operation system, the tables are linked by mechanic number field, which is called a common field because it connects the tables. This shows an example of the difference between the Mario's Auto Shop and Danica's Auto Shop. Danica's Auto Shop uses a database management system, and the Mario systems use two separate systems, so you contain data that must be entered twice. This is redundant and not efficient and can produce many data errors. In most organizations, you want to use the system that is similar to the Danica's Auto Shop. In file processing, it handles large volumes of structured data on a regular basis. It can be cost effective and is great for transaction processing. In a database environment, a database management system is a collection of tools, features, and interfaces that enables users to add, update, manage, access, and analyze data. Some advantages to using a database management system is that it's scalability. The system can be expanded, modified, or downsized. Economy of scale. Database design allows better utilization of hardware. Enterprise-wide application. A database administrator assesses overall requirements and maintains the data for the entire organization. It has stronger standards for data names, formats, and documentation are followed uniformly throughout the organization. You have better security because the DBA ensures that only legitimate users access the database, and different users have different levels of access. Its data independent system that interact with a database management system are relatively independent of how the physical data is maintained. The design provides the database administrator flexibility to alter data structure without modifying information systems that use the data. Here we look at some of the components of a database management system. You have the interfaces for the users, database administrator, and the related system. Users typically work with predefined queries and switchboard commands, but also use query language to access stored data. Database administrator concerned with data security and integrity, preventing unauthorized access, providing backup and recovery, audit trails, maintaining the data, and sorting the user. A database management system can support several related information systems that provide input to and require specific data from the database management system. Data manipulation language controls the database operations, including storing, retrieving, update, and deleting data. You have the schema, the complete definition of a database, including description of all fields, table relationships, is called a schema. The physical data repository is the complete definition of the database, including description of all fields, table, and relationship, is called a schema. When looking at a web-based data design, a data manipulation language controls the database operations, including storing, retrieving, updating, and deleting data. When you're connecting to the web, the objective is to connect to the database, to the web, and enable data to be viewed and updated. Sometimes it might include a middleware software that integrates different applications and allows them to exchange data and interpret client requests in HTML form, then translate the requests and commands that the database can execute. In a web-based system, It must be secure yet easily accessible to authorized users. Some terms that you might see in database is an entity. Entity is a person, place, thing, or event for which data is being collected and maintained. A table or a file contains a set of related records that store data about a specific entity. A field, also called an attribute, is a single characteristic or fact about the entity, and a record, also called a tuple, is a set of related fields that describe one instance or occurrence of an entity, such as one customer, one order, or one product. Other terms is a primary key, is a field or a combination of fields that uniquely and minimally identifies a particular member of an entity. A candidate key, any key that can serve as a primary key, is called a candidate key. A foreign key is a common field that exists in more than one table and can be used to form a relationship or link between the tables. A secondary key is a field or a combination of fields that can be used to access or retrieve records. When designing a database, it's important to have referential integrity. It's a set of rules that avoids data inconsistencies and quality problems. In a relational database, referential integrity means that a foreign key value cannot be entered in one table unless it matches an existing primary key in another table. In the example, you'll see that in the mechanic table, mechanic number would be the primary key. In the job table, it would be called the foreign key, and therefore you must have a primary key in the mechanic table before it can exist in the job table. With databases, you have a entity relationship diagram. The first step is to list each of the entities that you identified during the system analysis phase and to consider the nature of the relationship that linked them. There's three types of relationships when creating an entity relationship diagram. There's a one-to-one, a one-to-many, and then a many-to-many. In a one-to-one relationship, it exists when exactly one of the second entity occurs for each instance of the first entity. As you see, figure 9.15 shows example of a one-to-one relationship. In this instance, you'll see that one office manager can head only one office. One vehicle can be assigned only one vehicle ID number. The next type is a one-to-many relationship. It exists when one occurrence of the first entity can relate to many instances of a second entity. If you look at the example, it shows that one department can employ many employers. One individual can own many vehicles. The last type of relationship is a many-to-many relationship. It exists when one instance of the first entity can relate to many instances of a second entity, and one instance of the second entity can relate to many instances of the first entity. Typically, when you're dealing with a many-to-many relationship, you will have three entities involved in it. In the example here, we see that one student can enroll, many students can be enrolled in many different courses. Many passengers can make reservations on many different flights. Here it shows you an entity relationship diagram that has multiple relationships. So this is more a picture of what an actual entity relationship should look like or would look like. Now when looking at this, the way that you would read it is that you would have the entities involved in this would be a sales rep, customer, order, warehouse, order line, and then product. One sales rep can serve many customers, and one customer can place many orders. Many orders can be listed on many different order line, and many orders can be listed many products. One warehouse can store many products. So that's how you get the three, that's how you would read that particular diagram. Data normalization is the process of creating tables, designing by assigning specific fields or attributes to each table in a database. Normalization involves applying a set of rules that can help you identify and correct inherent problems and complexities in your table designs. The normalization process typically involves 4 stages: the unnormalized design, the first normal form, the second normal form, and the third normal form. There's actually a 4th and a 5th normal form, but typically you don't want to go past the 3rd normal form because it becomes too complex.